Welcome to another episode of the STELAR Project's Data Stories 360 podcast. I'm Sandra Kolaric, Dissemination and Communication Manager at Foodscale Hub, and I will be your host for this episode. Our guest today is Spyros Fountas, a professor at the Agricultural University of Athens and a member of the CrackSense Project consortium. His research focuses on precision agriculture, particularly in high-value crops, with an emphasis on technology adoption, farm management, and information systems. He has extensive experience working on digital agricultural technologies, and he has contributed to several research and industrial projects across multiple countries, as well as coordinating several EU-funded projects. I'm really glad you're here, and I can't wait to explore today's conversation about precision agriculture and the innovative technologies shaping the field. Now we can move to the first question. Can you tell us a bit more about your background and what first drew you to precision agriculture?
Yes, first of all, thank you very much, Sandra, and also the STELAR Project to this invitation for this podcast. I'm very happy to contribute to this. It's a very important project anyway. It's STELAR. I think it's going to be very helpful in the digital technologies applied in agri-food. So about my background, so I have been working on precision agriculture for more than 20 years. So it was started when I was a master's student in the UK at Cranfield University, that I was doing a master's degree in management information systems. And that was the initial phase that there were only a few farmers in the UK, the first 25 innovative farmers in the UK, that they had formed like a club to explore how precision agriculture could be applied. So a part of my master thesis was to actually visit all the 25 farmers and farms in the UK to see how they actually use technology and which are their problems in technology, or also the data adoption and so on. And then from that, I moved to Denmark. I did my PhD in precision agriculture with the supervision of Professor Simon Blackmore. Simon Blackmore, I think it's the godfather of precision agriculture in Europe, together with a couple of more people like Dick Watwin and John Stafford. They started precision agriculture. So I was very happy to work with him and apply precision agriculture and also agricultural robots. And then since I was in Greece, we've been working apply precision agriculture and digital technology in different cropping systems. And because Greece is a different system, small-scale farms, not so computer literate. So we explore also adoption issues, behavioral changes, how to make them more willing to work on precision agriculture.
I think that's the problem with many countries. Only few of them
Exactly.
have. It's always great to hear how different experiences shape someone's current professional career. And we will now move to some of the key milestones in your career that shaped your research direction. We just talked about a bit, but do you have something to add about some kind of milestones?
Yes, I think it's always nice to see how precision agriculture or digital technologies is progressing. First of all, I actually following the terms. Initially, we're say working on precision agriculture and precision farming. So for me, as I said, I started in 1998 when I did my first thesis on precision agriculture. So it's close to 20 years now. That was only precision agriculture, and we're looking at the variability within the field, just one single field. And all the work was about one individual field. Now, afterwards, with the use of many software to cover more farms, then things actually changed. That we're actually looking more at the farm and, these different states. And in the beginning, we're only using geostatistical analysis to analyze the data and to find the trends. So one milestone I could say was when in 2016, for example, the deep learning started, the AI models. So we were actually able to analyze more data from multiple fields and also bring more data within the same field to identify more similarities, correlations, and to predict, as usually we predict yield and quality. So AI paid a lot of attention, it was very important for precision agriculture digital because we can actually explore, explain, and predict better abiotic and biotic stresses. And another thing which I think it's very important is the recent years, as I said, it's that we don't only look at the technology now, but we realize that even we have the best technology, and technology is always there. So technology is always ahead of the explaining the agronomic models. So we really realize that the agronomic models are behind because technology is moving so fast with all of these developments. So agronomic model is very important to explain what technological data is giving us. And the second part is also what actually hindered the adoption of precision agriculture digital technologies. That's why also part of my group also we're actually exploring adoption trends, and also even we have some projects looking at behavioral research for digital agriculture.
Well, precision agriculture is advancing at this increased pace, and the end user adoption is delayed and not widespread. So, what are the most significant challenges you have encountered in managing precision agriculture for high-value crops? And on the other hand, based on your experience, what are the key obstacles that farmers face when adopting precision agriculture technologies?
Yeah, I mean, the challenges are quite many. I mean, we believe that in high-value crops, especially which are irrigated crops, that the management zones, I mean, will be more stable. So I say we could easily split the field in management zones and have different practices per management zones, which is not the case with non-irrigated crops like rain-fed, like cereals in Northern Europe that they don't irrigate. Then it's very hard to do actually management zones because the variability every year is very different. So I expected to have management zones more stable over the years. But then we realized that even with irrigated crops and we have permanent crops like permanent trees in orchards, permanent vines in vineyards, and so on, we realize that every year the variability is there, and we cannot have permanent management zones. So, because even the climate, and especially with the climate change, that influence a lot the variability. So, we cannot actually now rely on historical data. Historical data is good there to see some permanent problems, but we have to find ways to manage the fields within the season. So that's very critical. That's why we have to find ways of analyzing what's happening within the growing season and be able to have tools, technological tools, agronomical models to be able to deal with that. So that's I think one of the challenges we have. Other challenge we can say is as I said, technology is moving very fast, but agronomy is still behind. I mean, I'll give you an example. We've been working also in other projects related to pesticides, also based on for crop protection. And we can very easily collect a lot of data about weather data and about pest infestations, but there are not models available, many models for different diseases or pests, because and even some of them are really old and are not, let's say, fit to different countries. So we really need to have also agronomic models for different parts, like maybe irrigation is easier, but especially for crop protection or fertilization, that's something which is behind. Other challenges is yeah, the technology, we think that it's because it's developing that we expect it to be easier to use, but still for like a mainstream farmer, it's not easy. So we have to find ways to make it, I mean, applicable and easy to use by ordinary farmer, not to complicate it. And then we have another thing is we still don't have very strong economic models to persuade, like especially small scale farmers, but even large scale farmers, that this technology, specific technology for this specific, let's say, operation is good for you or is not good for you. So of course, the last year, European Union has realized this. So a number of projects actually are running and applied for this, and so we see there is a trend towards this. But we really need that at local level or maybe regional level, not like a country level.
And is there some like way to resolve this problem with like higher education with farmers on using this technology or something like that?
Yeah, I think most of the project I've been working on. I had one of my first EU project was Future Farm. That was FP7 many years ago, 2008. That we actually had the first EU project on digital agriculture in Greece. And then we did work, and then training and education was one of the main fundings. The second project that was coordinated was Smart Akis, was the smart technologies within the Akis, let's say, network. And again, what we figured out was in all countries, not only in Southern Europe or Eastern Europe, that farmers are a little bit behind in education, in training, that we need to have good training. I don't know what good training means, but something that actually makes somebody aware, not like coming and attend some workshop, but really have them use the technology like hands-on. We really need hands-on training with the farmers and make them or go to them to some fields or neighboring fields. And I say not at national level, it has to be at regional, local level that they should come and see and explore. Because if you take a farmer outside of his environment and take him to another region, they will not feel so comfortable. So it has to be within their environment that they know that. So it should be within neighboring farmers. And so that's the way we want to go and actually accelerate the adoption and, the use of technologies.
Thank you for the answer. Now, I would like to ask you, what are the main advantages of precision agriculture driven agriculture management compared to the traditional?
Yeah, I think it's what we keep saying for many years. Precision agriculture has economic advantages. We may not save inputs per se, but we optimize the use of resources. So we put the resources where it's needed, and we do not use them like on average across the field. So that means better organization and better optimization of resources. Secondly, it's of course environmental benefits, that we don't overspray, and we don't damage, for example, neighboring. So we reduce the spray drift, so we don't damaging neighboring fields. We don't overuse fertilizers or spraying. That means they don't have leaching within the soil to penetrate, I don't know, the water, the underground groundwater. And then of course it's social, that makes agriculture more, let's say, modern, because now the young generation, we all know, as I say, the mobile phone is extension of their hands. So I don't think there is any young person without having the mobile constantly of their hand. and they all want to use some apps, some technology, some techniques. So we make actually agriculture more attractive to young generation because we have technologies, and actually they can even control greenhouses remotely. They can see what's happening in their field with the cameras and drones, and so it's actually make it more attractive. And we don't say that that's to make it attractive, but it has a value. So we actually measure and explain what is the variability and different things within the field.
And to gather all those insights, you mentioned that you're using drones, probably sensors and other technologies, and that is all gathering vast amounts of data. So
Exactly.
agriculture is now filled with amounts of data, but its true value is often underutilized due to difficulties in accessing and using data spread across various formats and locations. So, do you think that the agri-food sector would benefit from a platform for intelligent data discovery, AI-ready data, and semantic and interoperability, as we are doing in STELAR? And what's your opinion about that?
Yeah, data thing is the future, actually. And we need a lot of data to train models. We need a lot of data to explain causes of problem, of stresses, of issues, and we have to train models. It's very hard, as we all know, to collect raw data at field at high quality. This is really hard. It's very easy to stay, to run models and we have good raw data. So we need a lot of raw data. We need good annotated data that to be used by machine learning models to explain what's going on, and then based on that we can then afterwards go to generative AI to create like new model and new data sets and explain the let's say costs that we're not aware of yet. So definitely we need such a data sets, platforms to be openly available to help the community to run models, algorithms, and I think for the good of everybody, actually.
Yeah. And looking ahead, what do you see as the next big frontier to precision agriculture? And how do you envision AI and machine learning advancing in this field?
I think we should see something like customized, individualized, let's say decisions per field, per farmer. So AI would actually help to personalize the decision and the outcome and make it fit to each individual, because everybody has got their own beliefs, their own, let's say, problems, issues with this really advancement of AI and also large language models and so on. I think it will be more easier for, as I said, we have to be user friendly to actually help a lot to make precision agriculture more, let's say, applicable to every individual farmer and agronomist in the future.
Yeah, and that is also the point of this whole story. So, yeah.
Excellent.
That brings us to the end of this episode. We are grateful for taking the time to be part of this conversation. And stay tuned for more Stellar discussions coming soon. Visit us at stellar-project.eu for updates, and see you next time.
Thank you. Bye-bye.